be talking about 4.6, analyzing quadratic functions of the form y equals ax squared plus bx plus c. We've already kind of done this. We've already talked about how to switch from the standard form to the general form, which this is general form right here. We also know from before the last test, we know how to plot parabolas using a table of values. However, there are more things that we can do to analyze a function in this form right here. So this right is the general form, and in general, we can get it to the form y equals a x minus x1 x minus x2, right? We can get it into that factored form. Sometimes the a is out front. What does the a tell us? Again, that's just the stretch factor. What does x1 and x2 tell us? Well, x1 and x2, they are the zeros of the function. Or another way that we can say it is they are the x-intercepts. So if I were to graph a random parabolic function like this, maybe it's a little too skinny, maybe it should be widening out a little bit more, but you get the picture. And we say that this guy right here is y, that looks like g, y equals a x minus x1, x minus x2. We say that this will be our x1, comma 0, so that's one intercept. This will be our x2, comma 0. Okay? Because it's going x in the x2 in the x direction and 0 in the y direction. Does it, let me put it on there. Does it really matter if I have x1 here, x2 here? No, it matters absolutely nothing. It's just a placeholder, that's all. Now, if we wanted to figure out what the axis of symmetry would be, in this case it's kind of right here. Okay? If we wanted to find out the equation, now this is the new spicy meatball bit. If we want to figure out what that is, we can say that it's x equals x1 plus x2 over 2. What are we doing? We're finding the average of x1 and x2. What's another way of saying it? We're finding the midpoint between the first root and the second root. Why does that make sense? Well, that's where the mirror line is. That's where the axis of symmetry is. So I want you to make sure that you have a star beside this one and say this tells us the axes of symmetry. That can also, just spoiler alert, that can give us our x value for our vertex, which then we can plug into the equation to get our y value of the vertex. So instead of changing this into standard form, we can just plug in the x value of the vertex to find the y value.